You should know the specific rule for the area of a triangle being half times base times height. Now that rule only applies for triangles that the height and the base are perpendicular. So more specifically, so if I have a right angle triangle, for example, or maybe a triangle with already the base and height perpendicularly defined. So if this is my base, then the height is going to be like this 90-degree length to the base. So the half times base times height only works for these general ones, for these specific ones. But we need a general formula that would apply for any triangle, even if we don't have the base and height. So this is where this general formula comes of half AB sine C. And this applies to the area of any triangle, but specifically with these lengths and angles. So you can dive into like the labeling, but the way I explain it is that it has to be half times. Now the relationship between A, B, and C is that C is sandwiched between A and B. So if I have the length AB, my angle C has to be sandwiched between them. And so to find the area of this triangle, all I have to do is take half of A multiplied by B, and I take sine C. Please be careful that it's sine and not cosine. There are students that confuse this. So you might get some questions where maybe the sandwiched angle is not included. Maybe you have the A and B, and then maybe you have these angles but not the sandwiched angle. So what you could do is just use the 180 minus these angles, get the sandwiched angles, and then use all of these three lengths together. Maybe you'll have to use the sine rule or the cosine rule to find this angle. So maybe you have to use other processes to find this sandwiched angle or the lengths, but as long as you maintain it the same way. So it has to be A, B, and C is the included angle. So that's the general rule. So as an example, we have this question and it's quite direct. So you have 8.6, 6.3, and 50 degrees is sandwiched between them. So if I want the area of this triangle, I'll just have to substitute in the formula. My lengths are there and then the sandwiched angle, and that will give me 20.8 meters squared. Now let's look into a more complex question. So this is where it's multi-layered. So you can pause and read the question if you want to. So for part A, they want the size of the angle AOB. So AOB, and you'd notice that we only have 7.5, but in the question itself, they've given us that the diameter is 10. And notice that you should be comfortable with lengths or triangles showing up inside of circles. Because AB lie on the circumference, it means, and O is in the center, it means that we're picking a point from the center to the circumference, and this by definition is the radius. So this is the radius and that's the radius, so be comfortable with these constructions. Now, what is the value of the radius? Well, if the diameter is 10, it means that the radius is half of it, so the radius is 5. So we have a radius of 5 here, and I have all three lengths. Now for part A, they want the size of the angle AOB. So they want this angle, so we pick the middle letter. But as you can see that we don't have, it's not a right angle triangle or anything. You can convert it if you want to, but we do have all the lengths, which means that we can use the cosine rule to find this angle. So using the cosine rule, it's the lengths next to it squared minus the opposite length to my angle. So the opposite length is 7.5, so minus 7.5 squared. And then the denominator is 2 times the other length, 2 times 5 times 5. And that's going to give me negative 1 over 8. Sorry, there are two equal signs here. To get the angle, I have to take cos inverse of that. So cos inverse of negative 1 over 8, that's 97.18, which makes sense because it looks more than 90 degrees here. Kind of. Never trust the diagram, but try to see if the number makes sense. And then part B wants the area of the triangle AOB. Well, that's good. We found the angle included between 5 and between this length and this length. So I can use the half AB sine C. So I have half times 5 times 5, and then sine of the angle included between them, which is what we found in the previous question. right, 7.18. And usually that's how questions would be set up. They won't just give you the triangle without the included angle. They'll probably add a previous step where you had to find this included angle. So then part C was the shaded area. Sorry, the area is 12.5. Now for the shaded area, we're looking at this orange area, and basically it's the circle area minus the triangle area. So the circle area is pi r squared, and then we take away the triangle area, which is 12.5. The radius is 5, so all of this will give us 66.1 centimeters squared. Quite a quick and easy rule to use, but I do want to include this like complex examples to show how you can apply it in a multi-layer question.